Welcome to this example using gatingcalculation.com. In this example, we will be looking at the casting shown in the sketch, which is made in BS 3100A2 alloy. It has a weight of 470 kilograms and the feeders weigh 290 kilograms. Our sketch shows the design philosophy we wish to use. The gating system is made of ceramics or hollowware, but the diameter of the pieces and gates are not yet known. We wish to find the most suitable starting point in our gating system optimization journey. This is because the ladle we will be using must be able to cast 3 of these castings in series, and the best starting casting temperature along with the pouring time and gating system sizes is very important to maximize our efficiency and quality. The total mold height is 600 mm or 60 cm, while the distance between the parting line and the top of the mold is 44 cm or 440 mm. The feeders have already been optimized in a simulation software program like Magmasoft. We are now ready to determine a good starting point for our runner design. This will help us reduce the amount of time spent getting a gating system completed. Our focus in the simulation program can be towards more creative solutions to maximize our competitiveness. In the example, the basic information has already been set up, which you can look at by pausing the video. By selecting yes, you can create a new runner system for this casting. The first required information is the alloy type. In this field we select steel. The type of mold will be set to sand mold. The sand binder type will be set to resin bonded, or any type other than the green sand or bentonite binder type. The gating system type will be set to ceramics or hollowware. As soon as you have selected this option, other fields will disappear. We will not select a filter at this stage. Our ladle will be of the bottom pour type. The estimated average geometrical modulus for this casting has been calculated to be 2.5 centimeters. You can also type in the value, that is half of the modulus calculated for the largest feeder, that will be used for your casting. Enter the total system height as 60 centimeters, and then the next field to 44 centimeters. The approximate metal mass above the parting line should be set to approximately the weight of the casting, and the feeders combined, as this is the weight of the entire system above the gates, when the metal enters the mold cavity. We shall type 760 kilograms in this field. You can set the number of turns the metal must go through to 3. The height of the pouring cup is obtained from the foundry, but for this example we will use 25 centimeters. The cup is placed on top of the mold, so please select this option. The draft angle is 0 as there is no pattern draft for the runner system when using ceramic runner systems. The height of the bottom of the ladle is about 10 centimeters above the pouring cup. We will estimate the total length of the gating system to be about 250 centimeters. Moving to the bottom, pour ladle section, we can populate the fields accordingly. An example ladle has already been entered in the ladle database. You can do the same for your own ladles. The amount of metal in the ladle is 3,000 kilograms. The nozzle diameter is 4 centimeters, and there will only be one nozzle for this example. The distance to the pouring cup is again 10 centimeters. This is the first casting to be cast in this series of castings. In the ceramics or hollowware dimension section, we need to fill in some information based on our design philosophy as shown in the sketch at the start of this video. For a nozzle diameter of 4 centimeters, we will need to use a hollowware diameter of at least 5 centimeters. The gate or duck foot diameter can be different if you choose. It will however also be 5 centimeters for this example. The number of gates is 4 as per our design. Since the metal stream splits as soon as it reaches the bottom of our gating system, we set the number of elbows before the first T-piece section to 0. The number of T-pieces is 3, and the number of elbows used is 6. This is required to determine the risk of metal choking up in the channels, which may lead to operator throttling the stopper during the pour. Updating the calculation will populate the remainder of the fields. The first information we need to update is the gating system mass. Since we don't know the exact mass at this moment, we need to use the estimated mass from the calculator and enter this in the gating system mass field in the basic information section. By updating once again by simply typing enter, you will notice the yield and pouring time is also updated. You will also notice the recommended pouring temperature appears. If you enter this value in the pouring temperature field, it will appear in the PDF works instruction. You can of course enter in your own value if you please. Let us determine the recommended pouring temperature for the third casting poured in series from this ladle. By typing 3 in the which casting is being cast field, we can see how the new pouring time affects the recommended pouring temperature. Just after the calculation updates, you can see a warning message appears. This is to inform you that the pouring time exceeds the square root of the total mass. What is of more potential concern is the recommended pouring temperature, which is 1600 degrees Celsius. This means that you will need to cast the first casting at a higher temperature, which may not be suitable. If the nozzle diameter is increased to 5 centimeters and the ceramic's diameter is also changed accordingly, the gating system mass increases accordingly. After updating the gating system mass, we can see the recommended pouring temperature changes to 1580 degrees Celsius. If we wish to see what the recommended pouring temperature is for the first casting in the series, we can simply change the which casting is being cast field back to 1. Now the recommended temperature is 1560 degrees Celsius. We will now enter 1580 degrees Celsius in the pouring temperature field, as it covers the first, second and third casting in the series to be cast. In summary, we have been able to use gatingcalculation.com to find a suitable gating system hollowware ceramic diameter as well as the appropriate nozzle diameter to cast 3 of our example castings. You have also seen that you can find a suitable starting temperature for this ladle. Some fields of interest are the maximum initial and then final metal velocity through the gates for the casting of interest in the series. This is to assist you in getting an idea of what to expect when the metal flows through the gates. The second field of interest is the potential metal splash height, which may help you minimize risks of poor surface quality due to splashing. You are now able to validate this in your casting simulation software package or trial it in reality. There are, of course, many permutations of this example. We recommend you explore the full capabilities of gatingcalculation.com to benefit accordingly. Thank you for watching this video. Like and subscribe to be alerted of more videos in the future.